Welcome. Thanks for joining me on this discussion of synchronous and asynchronous programming, in particular in relation to JavaScript. Now I'm going to start in a fairly unusual place. What I'm going to do is actually talk about the whole history of synchronous programming, what it all means and why it's so significant and particularly important with JavaScript. So to give you an idea, I might just give you a general introduction to the difference between synchronous and asynchronous programming. For some people this may be a little bit basic, so you might hang around for a moment, just see if you've got it covered. If you do, then skip ahead to the part where we get to the TypeScript. So first off, what I want to do is just think about in the history of time in all computing. Back in the days when we had, say, a console application. So this is the kind of thing that we see, black screen, just one thing going on. So in those days when we had things like MS-DOS and PC-DOS, CP/M, those kinds of things, the computer could pretty much only do one thing. It could do the thing that's on the screen, and that's pretty much it. It could also give you an illusion that something else was going on, but in fact generally what happens is actually a serialized sort of approach. So what I want to do is just give you a little intro by showing a common type of thing that we might have done in the old days and see how that progresses through and how that now relates to our TypeScript programming styles that we need to face. So the old days, on our black screen we might have a write line, and we're going to say into that waiting for a message. So it's going to indicate to the user that something's coming, just wait for a sec. So then we're going to wait for some time. Now I'm using DELPHI XE5 here, so it's a little bit modern to do an old thing, but we'll try and work around it. So we're going to sleep for 3,000 milliseconds or 3 seconds. Then we're going to write line a message like waiting for a enter key. Okay, and then we're going to give some kind of message to the user to tell them what they want, what you want. So how about we say something like, actually we'll give them back what they said in the command line. You said plus parameter string parameter 1. You said this. And then we're going to want them to hit the enter key, so we'll use read line. So that's waiting for the user to actually press the enter key. We're not going to do anything with the result of that. Then we're going to say, yep, well, we're finished now. We're done. And just so on these older screens, on the console screen, of course, we've got to make sure it doesn't disappear off before we finish reading it. So we're just going to put another read line after that. So if we were to run this, first we might need to put what parameters the user is going to say. So again, sorry, a little bit modern user interface here. Could have done it at the command line, but it's not worth the trouble for us. So I'm just going to say here, okay, just when I was practicing before I typed in this already, so I'll just use that again. And we're saying hello from asynchronous process, hello from sync. So now if we ran that, we get something like waiting for a message, waiting, and then it said, waiting for you to press enter. You said hello from sync, and waiting for me to press enter. I'm going to say done. Okay, that's not quite. The instructions are a little bit vague there, so I might just fix that up a little bit. And we're going to say something like, please press something like that. Okay, that might read a bit better. Okay, let's run that one. See, one of the things, it's a little bit small, waiting for a message. Now we've got a message that says please press enter. You said hello from sync, we did. press enter, and we're done. So that's an example of a synchronous flow. So we did a write line, and then we did a sleep for 3000, and then we wrote some stuff on the screen and asked the user to do something, and then the user did this, and then we said done, and wait for the something to happen at the end. So the process was totally top down. We did this, and we did this, and we did that. Now, one of the things about this is you can easily see what's going on. I did this, and this, and this, and this, and this. That's it. I'm done. Okay. In modern programming, this is a lot harder to see what's really going on in a program sometimes, just to do with the semantics of how the language and how the asynchronous program that you're using actually works. So if we move on a few years and we say, okay, let's. I'm just going to save this one off so that we can use it later if we need to. So that's pretty much our project done. So that's good. Now let's clear this off. Now, so we moved on a few years, and then we had Windows interfaces. So how we had a form here. Typically, we had something on the form. So we better put something on there. Now, just need to move this wing. Sorry, I was dragging the wrong spot. Okay, just need to drag that over. The first thing is in this example, we do want this window to pop up when we run it. We want it to pop up in the center of the screen. So I'm just going to fix that. We need something to write on, because in the old days there was just one thing. In Windows, of course, there's buttons and all sorts of different things. So we actually want something to write into. So I'm going to grab a Memo box, which is about as close to that black and white screen we had here. We're going to have white and black in this occasion, though. Got a little message up there. I don't want to see that. Just going to clear that out. Okay, but we essentially want to do the thing when the program starts, and in this case, the main form will pop up. So we're going to a lot of asynchronous things are going on actually in the background during a Windows application, but I'm going to simulate it as close as I can. I'm going in here. I'm going to go to the onActivate method, and essentially that's close to the start. It's not quite at the start, but it's close enough for us. So if we had our code from before, which I'll just, sorry, I might just have to, I'll just save this one off as well. Okay, I'm going to save that off. Okay, I just needed to pop back over and reopen our console one so I can get that text set. So I want to start with that and reopen our Windows version. Go to the same spot, look at the code, and okay, haven't done it. Events, I'm going to go to the onActivator method, and in there I'm going to paste that same code. Now, Windows, some of the things we won't need, we probably wouldn't mind saying that first thing, waiting for a message, that's probably okay. Although on a Windows, we probably want that to be a pop-up, so let's say pop-up instead. We're still going to want to wait 3 seconds, then we're going to want to say waiting for an enter. In fact, it won't be an enter key because again in Windows it's going to be a click, so we're waiting for an OK message. Okay, so waiting for an OK. And this part here, you said, well, what we'll do is we're going to use a pop-up, so we can use some of the Windows features to do that. So I'm going to say in DELPHI it's show message is a wrapper for that Windows API, and we can say we want to say the same message. We can say you said whatever was in parameter string 1. We don't need those curly that sugar that we had before to make the screen look a little bit better in Windows. We don't need a read line anymore because it's because we're using a pop-up, and that's going to be a blocking process. Again, this synchronization thing is a process that causes the program flow to go in a single direction and you can't do anything else. That's a blocking process, part of the synchronous procedure, and again, we don't need that. Now the other thing is we don't want it to write to the line, we want it to write to that this Memo box here. So that one's called Memo 1. I'm going to change all of the Memo, all the write lines to Memo 1. Oh, that's good. I had that from before. So I'm going to replace all of those. So now instead of saying right line, we're just going to say memo own lines add and show message and then done. So it's essentially the same program. Again, I know this is a little bit odd. It's not quite TypeScript. We're just trying to give you the idea that this whole process is, it's not a new thing. Synchronous programming, asynchronous programming is not a new issue. It's an old issue that we're addressing different ways nowadays. So last thing is we want to put our parameters in here. We should be lucky. It should be a message already. Hello from sync. Yep, we've already got that from before. And if we now run that, we're going to get our message waiting for a pop-up. We've got our pop-up. We're saying OK to that, and we're done. So essentially, this is exactly the same program. We need to, because it's Windows, we probably should make that a bit more beautiful. Let's do that. Nothing too much. Let's just go back to this memo. Go to the font, and just make that a bit nicer, a bit bigger. That's probably all we really want to do here. Should I do another thing? No, I'll just carry on for the moment. Let's start that up. So I'm waiting for a pop-up, and this is starting to look a bit nicer. But we didn't do a lot, but all we did was make the font a bit bigger. And we're getting the same message, hello from sync, and we're done. Now, let's just look at something closely here. This is a Windows program, but when I start it, you can see I can't actually do anything while it's waiting. And now that it's started, now I can do some things, and now I can move my window around, things like that. This is the async problem in a nutshell. We can't do top-down programming anymore like this, because I'm doing this in a single function. Everything has to go one after the other. Now that's not how Windows works. It's not how the web works. So how do we tackle this problem? Okay, so I'm going to just save this off as it is. I'm going to move on to how do we really do this in Windows? The standard approach that people would probably use in this situation is to use a timer event. So what we can actually do is we can say we can add a component which knows about system timer, and it will ask some of the system resources to say, hey, when something happens every whatever time, so 1000 seconds, we want something to happen 3000 milliseconds. So we know we wanted to do something. What are we going to do? We're going to do something. Okay, so we've got basically a method that says wait around for 3000 milliseconds and then do something. So the thing we want to do is this in here. We want to take that bit out, put that down there, and then we also want to manage that timer a little bit. So by default timers are enabled. I don't want it to start until the program starts, so we'll cause it to pause. The other thing I don't want is once it has fired, by default it'll just keep firing that same interval, and I don't want it to do that. So I'm going to ask it nicely. First thing I'm going to say timer1.enabled equals false, but that's in after it has fired, when the program first starts up, and after our waiting for a pop-up message. I'm going to say enable timer equals true. So what will happen is the program will start, the form will show, then it'll get this activate event, and then it'll say, okay, I'm waiting for a pop-up in the memo box. Then it'll say, okay, start the timer, we'll start waiting for 3 seconds, but you see that's the end of the function. So something else has got to happen later on. And so what we're using is one of the system hooks to say, Windows, let me know when something is ready to happen, and then when it does, do this with it. So this is the thing we're going to do when that event fires. So I think that's all we need to do. Now I've done that right, hopefully. If I run that now, we should have the same behavior, waiting for a pop-up. And then after 3 seconds we got the pop-up, and then we said OK, and then we're done. Okay, but you see straight away that the difference is it's a little bit hard to see what's going on. we've got this function that does something, and this other function, which might or might not be related, does some other bits. So we're starting to get a workflow disparity. We can't see what's going on. However, have we solved our synchronous problem? In Windows, we want to be able to do other stuff while this is going on. Let's just run that again and see. So if I start that, I can see I can actually move the window around, and I can, well, I wasn't quick enough then, but I could have done some other things in the window. Just try that again, just to go a bit quicker this time. Yep, I can do things in the window and move it around. Then our pop-up comes up, and we say OK, and we're done. Okay, so you see that's the goal we're looking for. However, there is another approach we can use here. This is probably fairly standard, but there's another approach that's a little bit closer to what I want to start talking about. Again, just reminding you this why we're doing this in DELPHI and not in TypeScript. What we're hoping for is just to demonstrate that the whole process is not really a new issue. This is the kind of things we've been facing since the early days of Windows. This whole asynchronous program. How are we going to let the user do something while something else is waiting to happen or coming around to happen but not ready yet? So we want the user to have a nice experience. That's what this whole thing's about. So old problem, old way of solving it, different approach, and the approach we're going to look at now is actually what's really going on under the hood when we get to the final solution. So just bear with me again here. So let's save this one off. Demo, I'm going to open back up our Windows one. Okay, so this was where we were here, just here before. So we had the timer. Okay, and what we're going to do instead is we're going to use a different approach here. What I'm going to do is make a new other and DELPHI file. Okay, this is where I want to actually make a thread object. So this concept of threads in Windows is, all the time the CPU is hopping between these threads. The different threads can run on different CPUs. So this concept is basically, I'm not just doing one thing at a time anymore. I need a way to be able to do more than one thing. I want the user to do something, the computer to do something, the computer to do something else. So we're going to make a timer thread here. We want to again have the same outcome, but we want to do it in a slightly different way. So I'm just going to save this again. I think I might rename that. Save as. I'm going to call this unit timer thread. And so that gives us a better, more meaningful name there. So just to have a look here, what is this? There's some information here. We're going to come back to that later. But essentially what happens is when this thread fires off, it will do some work. And what do we want to make it do? Okay, so basically we want to take over the process that was done by this timer. So we're going to need a way to say, hey, I want you to wait for some time, I want you to run some function, and I want you to show me a message. So what we might do is we're going to use that approach on this thread, make this thread object do that thing we want. So first thing we have to do is think about what kind of function we want. So I'm going to just create a delegate or object procedure will actually make it. So I'm going to call it a say method, let's say. Say method, which is a type of procedure which accepts a message of type string, and the whole thing is a type of object. Okay, so this is a type that it says. What I'm describing there is the type of function I want to get. So I'm going to say, we know our thread's got to deal with a function of some kind, and that's typically passed in. So when we could create a constructor with this kind of thing, and in fact that's probably going to be the simplest thing. So we want some kind of function that looks like something like wait, and then when you've finished waiting, I want you to run some function some kind. Then I want you to say some kind of message, and then I want you to, well, tell you that how long to wait for. Okay, so I want you to wait. And when that's finished, do some function. I want you to say some message and take about that long. So let's actually make that the signature of the constructor of our threaded class here, so that it'll read like that when we go to use it. So I'm going to say constructor. Spell properly. Constructor. Now, the basic method is create. We're going to overriding the original method of tthread_create, but we're using a different signature, so we don't need to override it with the override keyword. So we're going to say create. Now we're going to accept a function of type tsay method, and we're going to have a message type string, and then we want to wait a certain number of seconds, so we're going to say a timeout of type integer. That's going to be our signature for our constructor. So we go and implement that by saying, okay, so I'm going to need to store all of these things internally, so I'm going to need some private members. So we're going to need say method, and we're going to set that to a function. And we're going to need f message, which is going to be a type string, which is going to equal a message, and we're going to f timeout, which is going to be an integer, which is going to equal the a timeout. Okay, so I'm going to need to, so Pascal's very strongly typed, you need to actually define your objects very carefully. So that's going to be a tsay method. It's a new signature I created, delegate signature. A message is going to be a string, and a timeout is going to be integer. So now we've got all the things we need to do the thing that we want to do. Now, what are we going to do? So we'll have to implement that inside the execute method. So after we create this, we're going to execute something. So I've just remembered I've forgotten to call the default constructor. So I'm going to need two things. I'm going to say inherited create, and I'm going to pass in the false parameter, which just says, do I start pause, which I'm not going to start pause. Then I'm going to say, well, I actually want you to wrap up after, so I don't need to worry about it. So I'm going to actually say free on self.free on terminate equals true. So after you finish, I don't want to worry about trying to have to free any memory references or anything like that. So that's quite nice. And now if we come back down here, what are we actually going to do when this executes? So when we execute, what we actually want to do is that thing that we did in the original Windows message. We're going to want to do this thing. So this is the content of the function that we want to run, but to make it a bit easier, leave it inside that method. So we actually, all we really want to do is call our say message function. Firstly, you want to say sleep 3000 is what we wanted to say, but in fact we made that a generic, so we can say f timeout. We then say, okay, what function do I want to run? And then we're going to say, okay, call the method that we want to say. If assigned, which almost certainly will be, but we're going to just check anyway, f say method, then f say method with the message in it. Okay, so that's what we're going to do. Okay, there's just one little complication here though, because this timer, this whole thread management thing is actually, it's a fairly non-trivial process. You have to be very careful with two processes, two threads operating on the same parts of memory at the same time. So you have to actually be really careful about your thread safety in classical programming. It's actually one of the key differences, one of the reasons it's both easier and harder with TypeScript and JavaScript in general to deal with this whole asynchronous programming, because TypeScript actually doesn't have multi-threadedness. And I can hear screams out there. You saying what? What do you mean? You can't do more than one thing at once. That's what I'm saying. That's actually true. It can't. So that we have to use other techniques for doing that. It's both a blessing and a curse. The truth is that this synchronizing threads, multiple threads working together, has caused so much work in classical programming that somebody's stepped back and said, maybe that wasn't such a good idea. Maybe we needed a different process, different path, different way to do things. And in fact, that's exactly what's happening with Node and JavaScript programming in general. Thread management is fantastic stuff. It's difficult, troublesome, cause more trouble and delays in a project than anything else, trying to get this thread synchronity lined up. The problem is that, just to reiterate what this exact problem is, you've got one thread that's running along looking at a chunk of memory. Thread B comes along and it's looking at the same chunk of memory. Who's going to get control of it? The answer is, if you're not careful, both of them at the same time. So one process could be updating at exactly the same time as the other, and that just leads to disaster. So this part here about synchronizing, what we have to do to make this thread safe is we need to be saying that, okay, we just need to take a little bit of a step back. In DELPHI is to use a synchronizer, which I'm actually going to do that now, just to give you an idea about the level of trouble it causes. I'm going to say inside this protected area, I'm going to say that I need a method called doSay. So that's a DELPHI convention. You can do this or do that when you've got a synchronized thread. So I'm going to actually say doSay, and what I'm going to do is implement that. I'm going to put this inside the doSay, and I'm actually going to say synchronize doSay. Oops. Because that's what I actually want to do. I want to synchronize on the main thread. So meaning, if anything else on the Windows part is doing something, wait till there's an opportunity when it's not doing anything so I can give it this job. So the job I want it to do is actually display the message. Now, it's strictly not required because a pop-up is blocking. However, just for completeness, I thought I would include that little bit of wonder and joy in the process. So I think I've got that right now. So if we go back to our calling thread, we need to reference this unit. I'm going to grab that there. I'm going to need to reference it, but I don't need to publish it, so I'm going to put it inside the implementation. Oops, sorry, so my C# coming out there. Use timer thread. Okay, so instead of, now in our activate, what do we need to do? We need to create our thread. So what we can say is, using our new ttimer thread object, we can say tttimerthread.create, and we need a function. Let's call it alert, because that's what it is in JavaScript. Let's call it alert, and that's our function, which we haven't created yet. Now, next thing we need is a message. So our message is that which is the bit down here, you said parameter string 1. Say that, and the third thing we need is our timeout, which we said was going to be 3000 milliseconds. So we don't need any of those other things. This timer one, we actually don't need that whole method anymore, and we don't need this timer. And I think we're good then, just tidying up to make sure there's nothing left of that. Yeah, there is that one there, we need to get rid of that. Okay, so we know we've got this thing here, which looks a bit more sensible. It says Okay, I'm going to do a timer thread. I'm going to alert. I'm going to say you said something and wait for 3,000 milliseconds. But I need that alert function to just pass in. So I'm going to say procedure alert, and that is going to accept a message type string. That's what we need. And remembering this has to have the same delegate signature as the same method. So okay, so that's fine so long as that signature matches, which it does. So we've got a procedure which accepts a string, and we've got a procedure that accepts a string. So we're good. So in here we actually want to do the show message a message, and then we want to say, so what did we say down here before? Okay, we might just compare. We'll pop back for a second, just compare what that was. We'll just reopen part of the previous one. We don't want to do that. I'm going to reopen just that one there, just so we can see what we said. We were waiting for a moment. We said waiting okay, and okay. So I think we just need to actually grab that one and step back here because we want to say and show message. So it's essentially this method here without it. So it's really, if we'd copied that whole thing, actually we'll do that just so to make that a bit clearer. Except, okay, we're adding waiting for okay, and then we don't need to say that because it's already passed in message, and we're done. Okay, so theoretically, that'll give us the same outcome as before. Now we just check the parameters, say hello from sync, but now it's actually not sync, it's async. So it's asynchronous. Okay, hello from async, that's a bit better. So theoretically, if I've done everything right, which is not likely, but we'll see, that will have the same behavior as before. Waiting for a pop-up to move. Oh, we got the pop-up, and it says waiting okay, and we're done. Okay, so we did that a different method entirely using threads, and this is what our code ended up as. So I'm going to save that as file, save as sync Windows thread. Okay, so that really was the introduction. So what was the point of doing this exercise in a language other than JavaScript? It comes back to the history of asynchronous programming. So let's summarize what we've learned from the exercise. Originally, the process was very controlled. There's a single pathway for the program to execute. It was fairly restrictive. The user didn't have a lot of control. And when you looked at the code, it made a lot of logical sense. You could follow the flow. So the advantage is for the developer, program flow made sense. The disadvantage for the process is that it was very structured and there was nowhere else to go. We moved on then from code which was this, then this, then this, then this, and then finally we're done, to a process where we had to cope with the situation where there was parallel activities, if you like. It's not really a true parallel environment. What we have is a linear process that has to mimic a parallel environment. So the user wants to be able to do things while the computer's doing things. Now, of course, it really can't do that with the original model, where we had a timer waiting for something to do. The user could do anything it wanted. In fact, really, there's just a tight loop in reality, a tight loop going on with Windows waiting for some kind of input from somewhere. So it's just a loop. Is there anything to do? No. Is there anything to do? No. Is there anything to do? No. Then eventually, at some point, this timer, which is being controlled by the system hooks, says, oh, yes, there's something to do, and then the code branches at that point. So there's a whole lot of infrastructure hidden under there that makes it look like it's a true parallel process, but in fact, it's a linear one. It's just, and perhaps you might consider it to be a circular pathway where you get a chance as it comes round to do the next thing. Now, Windows is actually quite like that. The truth is that there's architecture in place that allows this linear process to keep looping around over and over the tasks that it is required to do. Now that is identical to what happens in JavaScript. The difference is that on a Windows computer we can actually take advantage of the system and actually truly set off another process. So this timer thing is terrific for waiting, but it can't do any real work while it's waiting. So that's why we moved on to the next process where we actually said, okay, I don't just want to wait for something to happen. I really want to go and do something else. I want to go do some other real work. And the reason I'm waiting is because that work isn't finished yet. So we were simulating some kind of work here by just doing a timer, but that model doesn't really work very well. All that's good for is waiting. Whereas the third model that we tried is I'm actually waiting for something to happen. As it turned out, in this case, we're just waiting for some timeout to end. But we could have easily been waiting instead of being a T timer thread. That could have been a T HTTP client thread where it's waiting HTTP response. It could have been a file IO thread. File IO thread. It could have been reading from a file or processing data from a file stream or any kind of thing like that. So this model simulates the kind of situation that we're truly talking about. We've got some real work to do. We have to wait for it to finish, but in the meantime we want the user experience to continue as normal.